Okay, I want to finish up this example that I've been working on. And the problem is to find the equation of a parabola, that is a second order polynomial equation that is of this form, a2x squared plus a sub 1x plus a0, that goes through these 3 points right here. The point x equals 2, y equals 2, x equal -3, y equals 1, and x equals 3, y equal -4. Now, I really just pretty much picked those 3 points out of thin air. And so we want to find the equation of the parabola that goes through all 3 of those points. And ultimately, what we're trying to teach here is that if there is an equation of if there is a parabola that goes through those 3 points, there is only one such parabola. There are not 2 parabolas that go through those same 3 points. And there's one equation, one parabola. Now, you can write the equation of the parabola as I have shown here. I've said y is equal to a2x squared plus a1x plus a0. In my previous video, I then used the fact each one of these points leads to a different equation that has to be solved by the coefficients a0 through a2. One point gives me this, the second point gives me this, and the third point gives me this equation. So I have 3 equations and 3 unknowns. The unknowns are a0, a1, and a2. And those 3 unknowns have to satisfy these 3 equations. And I solved those equations, and I went through the solution in the previous video. I found that a0 is equal to 39 over 5, a1 is equal to -5/6, and a2 is equal to -31 over 30. So that means that I can write the solution here. I can say that y is equal to -31 over 30 times x squared minus 5/6 times x plus a0 plus 39 over 5. So if my calculations are right, this parabola goes through these 3 points. So I'm going to plot this equation on my grapher. So here's the equation right here. Shown up here, y equals -31 over 30x squared plus or minus 5 over 6x plus 39 over 30. And here's the plot. Now, does it go through the point 2, 2? Let's see, this is 2.5. This would be 1, 2. And does it go through the point 2, 2? That would be this point right here. Yes, it goes through the point 2, 2. So it goes through that point right there. Let me try to pull this up here. Boom, that point right there. Goes through that point. Does it go through the point -3, 1? This is -2.5, -3, 1. That would be this point right here. So yes, it goes through -3, 1 right there. And does it go through the point 3, -4? So 2.5, this would be 3, -4. So it goes through that point right there. So yes, this parabola appears that no errors were made in the calculation, and that parabola goes through all 3 points. Now, one other comment I want to make, and that is, it's possible to choose 3 points where there is no parabola that goes through the 3 points. Okay, if there is a parabola that goes through the 3 points, there is only one such parabola, but it's possible to pick 3 points where no parabola goes through. For example, I could pick the point 0, 0. So that's going to mean it's going to go through the origin. I could pick the point 1, 1, x equal 1 and y equal 1. And I could pick the point x equal 1, y equal negative 1. There is no parabola that goes through those 3 points. Well, how do I know? Well, let's see if we can find an A0, A1, and A2 that will go through all 3 points. And let me quickly go through that. I have y equal to A2 x squared plus A1x plus A0. Now, if I plug in the point x equals 0, y equals 0, that gives me 0 is equal to A2 times 0 squared plus A1 times 0 squared. So all of this is 0 plus A0. So I have A0 equals 0. So now my equation looks like y equal A2 x squared plus A1x. Let's look at the point 1, 1. Okay, y is equal to 1. X is equal to 1, so A2 times 1 squared is A2. And A1 times 1 is A1, so I have 1 is equal to A1 plus A2. And then I look at the point x equal 1 and y equal negative 1, so that gives me negative 1 is equal to A2 times 1 squared. So that's A2. And A1 times 1, remember x is equal to 1, so I have A2 plus A1 is equal to 1, and I have A2, sorry, this should be, let me rewrite that, that should be A1 there. So I have, and this second one, it says A2 plus A1 is equal to negative 1. Well, obviously that can't happen. I could, the A1 plus A2 equals 1 and A1 plus A2 equals negative 1. That doesn't fly. If I subtract this equation from this equation, negative 1 from 1 gives me 2, and then A2 from A2 gives me 0, and A1 from A1 gives me 0, so I get 2 equals 0, which is an obvious contradiction. So I'm trying to find a parabola that goes through these 3 points. There is no solution. I'm going to talk a little bit more later in the course how we can determine if we have 3 simultaneous equations, or for that matter, any number of equations that might be of this form, if we can determine when there may be no solution to that to those problems. In other words, there may not be values of A0, A1, and A2 that solve a given set of 3 equations. However, the most significant thing here is that if we have a parabola that goes through 3 points, there is only one such parabola. So if we're going to specify a polynomial that goes through 3 points, it will be it will uniquely define a parabola that goes through 3 points. Interestingly, we could come up with more than one third-order polynomial that goes through 3 points. But again, we'll be talking about that in follow-up videos. So 2 points gives you a straight line. 3 points gives you, at best, one parabola. Okay, now let's go on and we'll look at 4 points, 5 points, and so on, and see what they tell us about the polynomials that might pass through them. So until next time.